Hi. So I think it was Christina who had asked about number 25 on the probability review. So I just kind of wanted to go through that. And the question said, students at Summer Heights High like to vary their walks to school. At each intersection, students randomly walk either south or east. Determine the probability that the student will pass the pool on their way to school to the nearest hundredth. So the first thing we're going to do is we're going to find the total number of paths home. So looking at that, we have 1, 2 south and 1, 2, 3, 4, 5 east. So we have in total, we have 7 factorial. But remember, we have to divide by the identical objects, right? So we have 5 going east, so that's 5 factorial. And we have 2 going south, so that's 2 factorial. So when we multiply through and get our total number of paths, we're going to get 7 times 21 paths. I'm going to just recheck that just to make sure I did that correctly, because I kind of did it in my head, and never a good thing to not check your numbers. No, 21 is right. So this is the total number of paths home. Now we're going to think about the paths that go by the pool. So if we are to highlight those, that means that we're talking about these pathways and these pathways. So in order for them to go by the pool, they have to travel on these pathways. So let's calculate that. Number of paths that go by the pool. Well, for the first section, so up here, up at the top, we have 1, 2, 3 factorial, and we have to divide that by the identical objects, which is 2 factorial. And then for the bottom part, so down here, we have 1, 2, 3, 4 factorial, and we have to divide it by the identical objects, which in this case is 3 factorial. So when we multiply those through, we'll get, this will reduce to 3, and this will reduce to 4. You can do the math there to do those divisions, but that will get you 3 times 4, which is 12. So for our probability, it's going to be the number of paths that go by the pool, so number by the pool, over the total paths, total. So that would be 12 over 21. And I can reduce that to lowest terms. I can divide the top and the bottom by 3, so I would get 4 over 7 for my probability. I hope that helps.